Hello, this is our intermediate algebra course. Today we will cover section 3.3, graphing linear functions. But before, have a look at the puzzle that we have for today. It doesn't have anything to do with graphing. It's just a crazy and different way of doing addition, of working out addition. 6 plus 9 equals 3. 5 plus 8 equals 1. And then what's be the answer for 4 plus 7? I don't know, but the guy in the picture shows very upset, in a hurry. Hurry up! Tell me the answer. He's pointing to his watch, and might be a clue. This might be a clue. So think about your answer, and we will check it later. And let's move to graphing linear functions. You remember the function notation is if you have an equation, and let's say this is function notation, the equation, the corresponding equation is y equals to x, right? So you just can write an equation using function notation. We will guess values for x and plug in into the function and find the value of y, or f of x. We have here two functions, f of x equals 2 times x, and g of x equals 2 times x plus 1. So let's find for each one of these functions the value. If I plug in x into f of x, f of 0 is equals to times 0, 0. If I plug in x 2 times 0 plus 1, so g of 0 equals 1. Now, x equals 1, f of 1 equals 2 times 1, 2. G of 1 equals 2 times 1 plus 1, 3. Now guess, let's plug in x equals 2, 2 times 2, 4, and g of 2 is going to be 2 times 2, 4 plus 1, 5. So clear. We will draw, let's use different colors. Let's draw g of x with red, f of x we will use blue, and the graph. One advantage about functions is you can graph on the same xy plane different functions, and you can identify them by the letter. One is going to be f of x, the other one is going to be g of x. So let's start with f of x. X equals 0, y equals 0. X equals 1, y equals 2. X equals 1, y equals 2. X equals 2, y equals 4. And we can now graph the line intersecting all 3 points. And we are now ready to find the other graph of the function g of x. Let's represent it using a different color, maybe red, and the points are x equals 0, y equals 1. X equals 0, y equals 1. X equals 1, y equals 3. X 1, y 3. And x equals 2, y equals 5. 2 and 5. Now the line intersecting all 3 points. Always try to remember, draw the arrows to represent that those lines, they actually go ahead, go all the way to infinity to one side, negative infinity on the other side. As you can see, we can graph different functions in the same xy plane. This is g of x, and the blue is f of x. We can compare, we can kind of identify based on the different equations, how they behave compared to each other, and yes, that's a good feature of functions. Now, next, we will talk about graphing linear functions using intercepts. Intercepts are special points where the graph crosses the x-axis and the y-axis. This point here where the graph crosses the y-axis, this is the y-intercept, right? The y-intercept, and that point over there where the graph crosses the x-axis is the x-intercept. Those are special points, have special names, and are actually very helpful as the points that are easy to find and are very helpful to define the line. Notice that the y-intercept on the graph of g of x equals 4x minus 8 is the point 0 and negative 8. And you can find the y-intercept if you have the function in that form. This is the y-intercept. This number, the constant number in the function, is the y-coordinate of the y-intercept. In general, if a linear function is written in the form f of x equals mx plus b, this is usually associated to the letter b, the y-intercept is the value of b. Cool. Very interesting information, because you can look at the function and you can tell me straight away what is the y-intercept. The y-intercept of this function, f of x equals negative 2.1x plus 3.6. Y-intercept is always 0, the x-coordinate, and y-coordinate 3.6. Sometimes you can just say the y-intercept is 3.6. We know that the x-coordinate will always be 0 of the y-intercept. Letter B, y equals negative 5x minus 1/3. What's the y-intercept? Yes, the y-intercept is negative 1/3. To find x and y-intercept, you have to make x equals 0. Let's start with the y-intercept. Make x equals 0 and plug in into the equation or the function, and then you're going to find y-intercept. If you want to find x-intercept, it's the other way around. You're going to make y equals 0 and plug in into the equation to find x. Okay, example 4 equals x minus 3y. Find the graph by plotting its intercepts. First, to find y-intercept, we will make x equals 0 and plug in into the equation. Okay, 4 equals 0 minus 3y. Can you find y? 4 equals negative 3y. Divide both sides by negative 3. So divide by negative 3 both sides. This will cancel out the coefficient negative 3 on y. Therefore, y equals negative 4/3. This is the y-intercept. Find the x-intercept now. X-intercept, you will make y equals 0, plugging into the equation 4 equals x minus 3 times 0. And this negative 3 times 0 becomes 0. That's an easy one. 4 equals x. X-intercept equals 4. Along with the intercepts, find a third solution. It's always good to find a third point. You know that with 2 points you can define a line, but with 3 points you can make sure the line is correct. You got the first 2 points right. If you have the third point, all are on the same line, you can be assured. Okay, let's plug in y equals 1, that's the solution. A third point, 4 equals x minus 3 times 1. 4 equals x minus 3 times 1 is 3. We will use addition property of equality, plus 3 on both sides. And this will cancel out, right? Cancel. 7 equals x. That means x equals 7. If y equals 1, x equals 7. We now can graph because we have 3 points. Let's plug in here the y-intercept. Wait a minute, this is a fraction. Now I'm confused how I will graph a fraction if we have units. You can change this into a decimal. You can use a calculator, change into a decimal. You're going to see that negative 4 divided by 3 is 1.333, something like that. So negative 1.3. X equals 0. Y equals negative 1.3 is somewhere here. Another point. This is the x-intercept. Y equals 0. X equals 4. And the third point, to make sure we got all the right points, x equals 7 and y equals 1. X equals 7, 3, y equals 1. Nice, the 3 points on the same line. And we will draw the line. Yeah, you can use red, and this is blue. Let's use red. Red. That is the graph of 4 equals x minus 3y. Great. Another example. Look at this equation now. 2x equals y. Graph by finding and plotting its intercepts. Be careful because I'm pretty sure this is a tricky question. Because look what happens. If we want to find y-intercept, we make x equals 0. So 2 times 0 equals y. Y equals 0. But then, to find the x-intercept, we will make y equals 0. 2 times x equals 0. Divide both sides by 2. X equals 0. Both x-intercept and y-intercept are the same points, 0, 0. It's the same point. What do we do? Maybe we have an answer. Notice that anytime 0, 0 is a point of the graph, then x-intercept and y-intercept are the same. You now don't have 2 points, you have just one. You need to find at least one more, or better finding 2, so we have 3 points to be able to graph the line. All right, let's plug in x equals 3. So remember, the equation is 2x equals y. 2x, 2 times x equals y, y equals 6. And we also can plug in maybe y equals 4. That's up to you to decide. 2x equals 4. Divide both sides by 2. X equals 2. The point here is x equals 3, y equals 6, and the point here is x equals 2, y equals 4. Now we have 3 points. See? 3, 6, 2, 4, and what's the third one? Yeah, 0, 0. On the graph, start with the 0, 0, then x equals 3, y equals 6, and x equals 2, y equals 4, and the line crosses all these 3 points. Draw the arrows because the line goes to positive infinity, negative infinity. The graph of 2x equals y is a line drawn through all the points, the 3 points that we found. Great. Special situations, graphing vertical and horizontal lines. Graph x equals -3. This is a special situation. Because x equals -3, we don't see any y, right? X equals -3. What is the value of y when you are guessing points? When you're writing down a table with 2, 3 points to graph the line. Let's try. Look, think. If x equals, let's guess values for y. If y equals 0, look at this equation. What is the value of x? Yes, -3. If if y equals 1, what is the value of x? Look at the equation, plug in x equals 1, we don't have y equals 1, we don't have any y, so x equals -3. Plug in now y equals 2. This is crazy because there's no y. That means it's still x equals -3. No matter the y that you plug in, you're always going to have x equals -3. So find on the xy plane, -3 is right here. No matter the value of y, x will be always -3. And look what happens. You're going to have a vertical line. Makes sense? Every time you have an equation x equals to a number, the graph will be a vertical line. Another situation, a different situation now. We have y equals 3. It's kind of different, but you can think in the same way. Let's try to plug in values for x and check what happens with y. Plug in x equals 0, but the equation is just y equals 3. There's no x. X doesn't change the value of y. Plug in x equals 1. Plug in x equals 2. Always 3. Now y equals 3. If x equals 1, y equals 3, x equals 2, 3, 4. Look what happens. In this case, we will have, as a result, a horizontal line. A horizontal line. Oops. A horizontal line on crossing y-axis and y equals 3. Okay. All right. The graph of any equation that looks like this, x equals to a number, will always be a vertical line. We will have the x-intercept, but look, we don't have any y-intercept. The graph is parallel to the y-axis. And if you have y equals c, or the equation y equals to a number, the line will be always horizontal, and we will have y-intersect, but we don't have x-intercept. The graph is parallel to the x-axis. That's all for today. No, we have a different challenge. Hurry up, tell me the answer. The hint is on the picture. Look at the picture. He's pointing to the watch. So yes, you're getting why this addition is kind of crazy. 6 plus 9, think about time. 6 hours, 6 a.m., let's say, plus 9 hours is 3 p.m. 5, let's say 5 a.m. plus 8 hours is 1 p.m. And what's going to be 4 a.m. plus 7 hours? 11 a.m. In this case, we don't have any change. All right, thank you for watching. If you have any questions, send me a inbox message using Canvas. And don't forget to answer the questions in MyLab Math about this section.